As the world gets bigger and more connected, we need that sense of intimacy more than ever. So that's why I believe privacy gives us the freedom to be ourselves. This is the next chapter for our services.
Please meet the new Messenger. As the Messenger architecture becomes fast, as it becomes private, and as it becomes interoperable, we plan to make Messenger the fastest private communication app on the entire planet.
No matter where you live, WhatsApp is a messaging service that is simple, reliable, and above all, private.
It all starts with a fresh new design that is simpler, faster, more immersive, and put your communities at the center. Whoever you are, Facebook is here to connect you with your tribe.
Our mission is to connect you with the people and things you love. We have both public and private spaces on Instagram, and it's our job to find the balance between those two and to take a privacy-first approach to all that we do so that all of you feel comfortable telling your story.
Video calling is one of the most private ways we connect with family and friends, and that's what led us to Portal. Private connections with the people you're closest to are at the heart of the Portal experience. With end-to-end encryption in WhatsApp and Messenger, your Portal calls will be even more secure.
Augmented reality allows us to create content and experiences that add new dimensions to our lives. Since the last F8, more than 1 billion people have used Spark AR experiences across Facebook, Messenger, Instagram, and Portal.
We're announcing new features for Oculus, and our path begins by broadening access through innovations in hardware. It's through VR that you get an intimate sense of presence and place, that you can share these moments both touching and thrilling.
This privacy-focused future begins our next chapter. Society's biggest opportunities and most complex challenges aren't going to be solved by one person, not one team, not one company. We have to ultimately find ways to work together.
For us, this is about building the kind of future that we want to live in. So if we work hard and deliver this vision that we've laid out today, then I'm going to be proud of the difference that we've made.
Good morning, everyone. Sorry, I didn't hear you. Good morning, everyone. There we go. Okay, welcome to day 2 of F8. Day 2 is where we get to talk about the future we are building together. Now, I'm as optimistic about that future as I've ever been. And it may surprise many people watching this to hear me say that. Because it's true that we and I have learned a lot of really hard lessons over the last few years. And those lessons have fundamentally changed the way we develop and build new technologies, made us realize the deep responsibility we have to understand not just all the amazing good that can come from new technology, but the bad, the unintended consequences, the ways in which people may abuse those new technologies. And we have to take those considerations in mind with every new thing we build. And so how do we do this? You know, in preparing for this, I was hoping to give you the easy 1, 2, 3, the simple, responsible innovation playbook. But it doesn't work that way. The challenges we are facing range from things like election interference to misinformation to hate speech. These are deep, hard, broad problems with adversaries, so they adapt over time. There aren't simple answers to these complex problems. Instead, what we've decided is we have to dedicate ourselves to getting into the details, to working these problems day after day, month after month, year after year. Let me tell you how we've been approaching this. It starts with making sure that in every product we build, inside the product team that builds that product, we have embedded teams focused on all the ways in which those products may cause harm, either unintentional or through bad actors. They are detailed and understand the nuances of that specific product and sit right next to the people building all of these new features. Our products are broad, so they have different challenges. To give you a sort of spectrum of the challenges, you heard yesterday about Facebook and the focus on Facebook groups. Groups don't exist on Instagram. So the Facebook team has to worry uniquely about the challenges of group norms and what role a group moderator ought to play in managing harm in the group. On Instagram, there's a lot of influencers and public content. So notions of well-being are a key focus for the Instagram team. And the power of VR is true immersion, and that presents a unique set of challenges when dealing with social experiences. When two people are together in a virtual world, the sense of physical safety and physical comfort, how close is someone standing next to me in this virtual world, becomes a paramount issue and something the Oculus team has focused on deeply. Now, these embedded teams become experts in the products they're working on, but they need the help and support of subject matter experts that range all of the issues we face. So whether it be security or privacy or how to deal with misinformation or safety and care or algorithmic fairness, we have centralized teams who are dedicated experts in each of these areas that these product teams can then rely on. But of course, the other lesson we've learned is we can't and we shouldn't do this alone. Many of the challenges our products, and probably yours as well, have in the world have great societal impact. And so we need to engage with experts whenever we can, before, during, and after product development. And again, here the issues are broad, so we need to engage with a spectrum of organizations on each and every one of the core issues we're facing. As an example, when we're working on suicide prevention, we do so with organizations like Save.org and the National Suicide Prevention Hotline. When dealing with the terrible issue of child exploitation, we'll work with the US Center for Missing and Exploited Children and Internet Watch UK. These are just a few examples of the sort of organizations we're engaging with, and we're accelerating our engagement across the board in each of these issues, and we've been working with hundreds of experts to make sure we have the broadest set of perspectives on how we build this. Now, of course, you came here today in day 2 to talk about technology, and this is where we're going to focus a lot of the rest of today's talk, the technology that underpins the answers to a lot of these problems. It requires us to build centralized platforms that span the range of the issues and the teams that we focus. And it allows us to concentrate our investments. So when we make a state-of-the-art advancement in natural language processing or speech recognition or computer vision, we can apply that to not just each problem area, we can apply it to each and every product team. Let me talk about this using a couple of specific examples on how we're facing these challenges. You heard a lot about Portal yesterday. How many of you used a Portal? Raise your hands. Awesome. Okay, so if you raised your hands, you know what I'm talking about. Portal is the best experience, bar none, to connect with someone who may be thousands of miles away. And what makes Portal work is this core feature called a smart camera. You can see Portal up here on the right versus a tablet here on the left. If you've ever done a video chat on a phone or a tablet, you realize immediately you've just turned yourself into a full-time camera person. You're chasing around what's going on in the room, especially if you have little kids like I do. And instead of being in the moment and being there with the person on the other side of the screen, you're sort of futzing with the device. And what AI camera does is it does that job for you. So you can relax, enjoy what you're doing, play with your kids, cook your meal, and do so with your loved one who may be thousands of miles away. This is an amazing experience. But we knew if we were going to put an internet-connected camera in your living room from Facebook, we'd have to have deep technical protections for your privacy. The technology that powers the smart camera is called pose detection. It's something we've talked about in prior F8s, and it's the ability in a single 2D camera with no specialized sensors to figure out where the people are in the scene in real time. A few years ago, when we dreamed up this product, this technology was in the research phase, running on GPUs on big machines. And so we could have shipped this product a lot sooner by doing this processing in the cloud, sending video frames up, processing them, figuring out how to pan and zoom the camera. But we knew that was not going to accomplish what we wanted in terms of privacy and security on the device. So instead, we said, we have to optimize this algorithm and make it work on the local machine. You can see our progress here. This is August 2017 versus August 2018. If you look really closely on the one on the right over here, you'll notice that for quite a while, the algorithm is picking up a couple of the potted plants in the background as people, and you'll see the boxes snap in and out on the left. If you implemented this in the product, this would have meant that the camera was going to be moving around as it caught new things. Here we are a full year later, still months before ship, and this is the sort of investment in time and energy it takes to do this right. And because we did this, we don't have to send video frames up to the server to process them for Smart Camera, protecting your privacy. But the challenges with Portal aren't just about privacy. If we had trained this algorithm I just showed you on a limited data set, it wouldn't work well with different ages, gender presentations, or skin tones. And the team realized this early. So Lada, who you're going to hear from later, took it on herself to make sure we built a representative data set and a process that made sure that this algorithm was trained on a wide range of people so it worked for everyone. This sounds trivial, but if you put this really bluntly, if we hadn't have done this work, people would be cropped out of the video frame based on how they looked. This is the sort of mistake you want to catch before you ship a product and not after. Now, because we do this, we can enable these great experiences on Portal. Whether it be a grandmother who's recovering from brain surgery, keeping sharp by keeping in touch with her family, or grandparents seeing the first steps of their grandchild thousands of miles away, or an American playwright spending more time with her children because she can keep tabs on her play using Portal. When we do this work right to prevent the bad experiences, it opens up the window for us to create these new experiences that only new technology can build. Now, of course, this is a nice pad example of a specific product that shipped in a relatively honestly contained set of issues. But many of the challenges we face are actually much harder. When we talk about the battle of problematic content on our platform, these issues are broad, they're deep, and we're dealing with people who are trying to get around the defenses we're building. We've talked about the different categories of what we call policy-violating content, stuff we don't want on Facebook, publicly, every 6 months, in a thing we call the Transparency Report. And we do so in 8 broad categories of content. I'm going to share with you some information from our most recent report in Q3 of last year. Now, when talking about this, we're going to get into lots of details, but I want you to remember the goal here. Because presented this way, it's actually quite simple, or it seems easy in a single sentence, which is we simply want to reduce the prevalence, how much this stuff is viewed, by taking action, which is either downranking or deleting, violating content, which is the stuff we don't want, proactively, which means we'd like to catch it before someone else tells us about it, and also we'd like to make as few mistakes as possible, because you don't want to catch some good stuff on your way to catching the bad stuff. Now, teasing apart every one of these things is too much for this 20-minute talk, so I want to talk to you a bit about how we're dealing with proactive takedowns, because that's where technology really has a role to play. Starting with prevalence, and just to get a sense, prevalence is actually quite hard to detect for many of these things because of the small volumes, but we've published prevalence in 3 out of the 8 categories of these, and you get a sense of 3 to 4% for monthly active users that may be fake, or 0.1% to 0.2%-ish of violence or nudity or pornography in terms of content that we have on the platform. But percents are one thing. What it doesn't give you is a sense of the absolute scale. And this is where the numbers get a little mind-bogglingly big. You have to look very closely to see the units on this chart here, because it's in billions. In a quarter, in a 3-month period, we're taking down billions of pieces of spam, 700+ million fake accounts. Thankfully, you have to go down 2 orders of magnitude to get to the next categories, nudity and violence. That's in the tens of millions. And you have to go down another order of magnitude to get to the stuff here that's truly awful. But one way to say how effective are our automated systems doing is, given all the content we take down, whether we found it or someone else found it, how much do we find before someone else finds? Now, again, this is different than prevalence, because we may be very good at taking some stuff down, but maybe we miss some stuff that's got wide distribution. So you've got to take all these factors into account. But if you look at this, you get a sense of where we're doing well and where we face some challenges. In hate speech and harassment and bullying, we have a lot of work to do. But the question you have to answer yourself is not, how did we get where we are right now, but how long did it take, and what's the progress? What does the future look like? That's the question we're trying to answer today. And so if you go backwards and you look at the last 5 or 6 years, what you see is a steady investment in AI technology has caused us to make steady progress in attacking each of these areas. So instead of looking at percents immediately, if you just look at this over time, and you ask yourself 2 very simple questions. For each of these different categories of content, when was the first time machine learning became effective at all in proactively detecting some of this content. That's the hashy marks here. And when did machine learning become more than 50% of the content we take down, including all of the content reported to us by people? That's the solid bar. You can see we're making steady progress from not working at all to working to being the #1 source of reporting across each of these categories, even when we can get into these really, really hard categories. But again, numerics are hard for people to understand, so I'm going to take you through a very specific example of the progression of these technologies. Now, a lot of this content is really awful. So I'm going to pick the most benign possible example I could find. This is a piece of violating content where people are trying to advertise marijuana on Facebook. Okay? It's against our policies because it's against US federal law. So you can't advertise marijuana on Facebook. And if I took you in a time machine back to F8 in 2014, and we were talking about this subject, and I said, what are the ways in which we can proactively detect people trying to do it? It was amazingly and surprisingly limited. We had behavioral signals. Has this advertiser been caught for doing bad stuff before? Or are they coming from an IP address that we know is a known bad actor? If they did some silly things like use some obvious words like drugs or marijuana in the post, a basic keyword detector would be able to catch this. But the most surprising thing is, in 2014, computer vision, the study of AI to understand images, was so far away from where it is today that it had no idea what this was. I think this image is pretty obvious to most people in the audience. Anyone confused about what I'm showing on the screen here? Right? So surprising was we could not understand the content from computer vision. Let's see where we've gone. This is the audience participation contest. This is either tempura broccoli or marijuana. By show of hands, tempura broccoli? Okay, marijuana. Okay, how about this one? Tempura broccoli? Marijuana. Okay, you were not 100% accurate. On the left, this is what our computer vision system has to say. It is definitely marijuana. On the right, that is definitely tempura broccoli. Okay? That's state-of-the-art computer vision circa now. Okay? But as I said, we're dealing with adversaries. They're trying to evade our systems. So the obvious pot photo moves into something that's a little less obvious and maybe mistaken for a delicious fried food. So as our systems get better, they adapt. Each one of these examples is a real example of a piece of content that was taken down by our automated systems. This is packaging of marijuana. People realize that if we can catch the images of marijuana, they'll move to something more obtuse. You have to really stare at this stuff. If you got up close to it, you could kind of see what it is. But it takes you more than the 10 milliseconds it took you to see that first photo, right? The way we're able to catch this is through something we deployed just late last year, which is using the concept of a nearest neighbor classifier. Our Facebook AI research team did some pioneering work building a new algorithm for nearest neighbor search. It's 8.5 times faster than the previous one. It means with a very small number of samples, so if someone reports something like this, we can then fan out and look at billions of images in a very short period of time and find things that look similarly. So as soon as our adversaries adapt, instead of having to retrain a classifier over weeks or months, within an hour, within a few hours, we're able to catch very similar things. But again, people are getting smart. They adapt. This looks pretty much like Rice Krispies, right? People see the photo? Nothing wrong with Rice Krispies, right? It's not common to describe Rice Krispies as potent, which is what the text says. And I think $8 to $10 is a little much for a pan of Rice Krispies, personally. So now what you have to do is the image itself, 100% benign. Nothing wrong with advertising Rice Krispies on Facebook. Go nuts. I love them. It's a delicious snack. But what they're actually doing here is trying to use coded language in the text. And so what we have to do is put all the signals together. The pixels in the image, the text in the post, the comments, the poster, and we feed all of that into a state-of-the-art multimodal classifier that's not just looking at computer vision or NLP, but puts it all together. And this is a real example of a real ad caught by automated systems. So we've gone from embarrassingly obvious to you have to stare at it for quite a while to figure out why the heck I'm talking about this as a bad ad on Facebook. And this is pretty amazing progress. But I want to be clear, we're a long way from perfect here. Anyone watching this probably wouldn't have to work very hard to find an example where we make a mistake today, either because our technology isn't up to snuff, we didn't operationalize it right, or clever people figured out a way around our latest generation of this. This is an intensely adversarial game. We build a new technique, we deploy it, people work hard to try to figure out ways around this. And when you think of the scale of the problem we're talking about, remember I showed you billions in a month of problems, and that's just problematic content. That's not the billions of good content that happens every single day. And you think of this breadth of the problems, from election interference to hate speech to bullying, it can seem overwhelming. And this is where I understand why people are skeptical of us when we say we think AI can make a huge difference in solving this problem. And if I thought we were stuck in a world of building manually labeled, curated data sets and taking weeks to train specialized classifiers for each problem, I'd be skeptical too. But we're not. We've seen a number of breakthroughs in basic technology that are breaking us out of this current state. The basic technology that's powered most of what we've progressed over that last 5 years is called supervised learning. For those of you who aren't AI or ML nerds in the audience, I can explain this to you in 15, 20 seconds. It's not that complicated. You take a set of data, like a bunch of pictures, take a set of people, they meticulously label those pictures, describe everything that's in them, what all the images are, label them. You build a big enough data set with that set of people, I can build a machine learning classifier that can identify anything that was found in this data set. And we've made tremendous progress in the last just 5 years. This is why our computer vision systems can catch those examples that I showed you. But this has a couple of big problems. The first of which is they tend to be fairly specialized. If we didn't have something in the training set, we're not going to be able to detect it at production time. The second is this is like surprisingly manual and slow. It can take you days to weeks to months to go through the whole process of collecting, labeling, training, testing, validating, and deploying. And the stuff I'm talking about, people are adapting every single day. But the future here is pretty exciting. We've seen a number of breakthroughs just in the last 2 years in the idea of self-supervised learning. The idea here is pretty simple. Instead of having this manual labeling step, you sort of skip to give a big pile of data to an algorithm that can then train and learn based on that data. And the concept here is deceptively simple yet again. Let me actually take you through the basics of this. I'm going to use an example of our colleagues from Google who released a system called BERT, which is used for natural language processing, or NLP. But what they said is, hey, instead of building these manually labeled training sets, what you do is you take a big pile of data, say 80 million documents, and you take the sentences in those data, and then you automatically adjust them in some way. In this case, you mask out certain words, and then you train an algorithm to try to predict what those missing words are. And the cool thing about this is you masked out the words, so you know what the answers are. You sort of generate the training set and the answers all in once, and this can be done fully automatically, which means you can use massive volumes of data. And what's most interesting about this is because you're using so much data and doing this in an automated fashion, these NLP systems are starting to catch deeper and more nuanced understanding of language. And we've developed and deployed similar techniques like this in production for things like our most challenging problems, like hate speech in the US. But it doesn't just stop with NLP. Our teams at Facebook AI Research took this same concept and figured out how to apply it to both machine translation and what we'll call cross-lingual classifiers. The world doesn't speak just English. 6,000 languages spoken around the world. Our systems need to work in every single language. So instead of building this data set for every single language, you can instead take classifiers and actually train them concurrently to understand a concept, like is this talking about an election or civic discourse, and do so cross multiple languages at once. You can do this for computer vision. Take a set of input images, mask out one part of it, or turn it into a puzzle, train an algorithm to recreate the original image. Again, you've sort of developed both the test and the answers to the test automatically. No laborious process involved. You can do this with video understanding. Our research teams came up with a new technique to doing this, where you take a video clip and the audio that comes with it, and you're just training an algorithm to figure out whether this sequence of audio matches this sequence of frames. If you think of this intuitively, if I've got a video clip of someone playing a guitar, the algorithm is actually learning that when the pick hits the string is when the sounds of the guitar happens in the audio track. And by doing so, it starts to understand some structure of this video. You can do this for speech recognition. Similar technique. Is this waveform similar to the one before it? Is it the words coming out of my mouth, the waveform that comes there, the right one to follow, the one I just said, or not? Again, our research teams have figured out a way to do this in a system called Wave2Vec. They compared it to a supervised training system that used 12,000 hours of manually labeled data, where you pay people to listen to something and write down what it is, transcribe it. And you use a little bit of supervised data at the end, just 80 hours, and you get actually slightly better results. So it's several orders of magnitude reduction in work. So imagine if I said you need to get 80 hours of transcribed audio versus 12,000 hours. You can do that much more quickly with a lot less work. So this technique of self-supervision is working across multiple modalities: text, language, computer vision, video, speech. And this stuff is real. I'm not just talking to you about research papers in a research lab. We deal with real problems in the real world. One of the most important things we're working on right now is making sure that we protect the integrity of the Indian elections. 900 million people in a massive exercise of democracy, but they speak 22 languages written in 13 scripts. It is our job to do everything we can to combat misinformation and coordinated interference in these elections. Self-supervised learning is in production, deployed as a defense in many ways against these bad actors and adversaries in this election. We're using this concept of self-supervised back translation, which improves our machine translation systems so that when we build classifiers, we can get them in more of those 22 languages. We've built a self-supervised system that learns a deep graph embedding of all the nodes in the Facebook graph. So if you can think of this, if you have multiple Facebook pages, or maybe multiple WhatsApp accounts, and they are all pretending to be different, but in reality, they're run by a centralized entity who's trying to spread misinformation. You might see almost every week now or every other week, we make a post about taking down coordinated actors across Facebook and WhatsApp. One of the key weapons in our fight is an AI system that's trained to help us understand the relationship between these nodes. So if we find one of these accounts or one of these pages, we can figure out that actually all these other ones are related to it in this graph and take them all down at once. So these are real techniques deployed in production, helping us in our fight against these problems. So this is how we think about this. There isn't a simple answer. There is a lot of work to do. And we have to dedicate ourselves to reducing harm, preventing bad by us, by others, at every single layer of the stack. And our work here is never going to be done. Solutions will never be perfect, but we have to keep going. And this is where I think optimism about the future is really important. Because I tell you, where we are now, when you stare down some of these problems and you look at the magnitude of them, the difficulty, the breadth, the real-world impact it has, it's really easy to lose hope, to want to pack up and go home. But we can't do that. We are here to bring a better future for people through technology. And it is true that there are so many experiences that cannot be created without new technology. People making connections, building bonds, finding their community, raising money, finding help. All of these are happening every single day, right now, through the internet, through Facebook, through lots of other products. So our job is to preserve that future where we can use technology to make these amazing experiences and connect people while doing the things we need to do, holding up our responsibility to prevent all the bad and harm. And if we do that work well, we earn the right to build that future. We're going to spend the rest of today talking about these concepts in a lot more detail. We've got a lot of exciting technology and specifics to talk you through. To kick this off, I wanted to introduce Manohar, who's going to go deeper on the AI work here. Thank you for coming to Day 2 of F8. Thank you.
Facebook today could not exist without AI. AI is used to build fundamental, compelling experiences across our platforms. It is also our best bet to keep the community safe. across our platforms. At our scale, with billions of pieces of content, tackling hundreds of problems with as little latency as possible, AI needs to understand the content and do it with less supervision. That is our goal. In a simple plot, here is our goal. Across the various problems, how we are doing with respect to our goal. On the x-axis, you see understanding content. As AI gets better at understanding content, we can move the dots to the right. On the y-axis is the amount of supervision we need to train these models. As we can train models with less labeled data, we can move the dots down. Or better yet, we can do both together and move faster towards our goal, our North Star. I know in this case it's in the south. There are many ways people communicate on our platforms. And over time, it has gotten richer. First, let's look at language. In order to reduce bad experiences on our platforms, our systems have to understand when people write something that violate our policies. Now, I don't want to give bad content any airtime at F8, so today I'm going to stick with benign examples. Let's say I made this post. Under the hood, our AI systems are trying to answer all of these questions. Is this content hateful? Is this about bullying? Am I trying to sell something? And so on. To do this, our AI systems need to train on thousands of examples. There are more than 6,000 languages spoken on our planet, and we support a lot of those on our platform. How do I answer all of those questions in all the languages we support when we don't have enough training data? Now, we talked about our unsupervised translation efforts. Last year, we published work where we can map words in multiple languages together in a representation space, and if they mean the same thing, they're mapped closer to each other. Now, we can do that with full sentences. In my home, we speak 3 languages: English, Telugu, and Hindi. Now, no matter which language I use, when I compliment my wife, she gets it. When I argue with her, she definitely gets it. That's because the meaning stays the same in all these languages. This is obvious for us. For machines, it is not. Previously, we needed to build a model for each language. We found a way around this. We trained a model where multiple languages live in the shared representation space, and if 2 sentences mean the same thing, they are mapped closer to each other in this learned representation space. This gives us a powerful tool to think about language problems in a language-agnostic way. Let me tell you how we do it. We take this sentence, we take the words, pre-process them using byte pair encoding. It's a standard process in language modeling. Use a bidirectional LSTM model with a bunch of layers. And because the words can be numerous, sentence can be of variable length, we use the max pooling operation. And this gives us a sentence embedding. The input is a sentence, and the output is a sentence embedding. This entire unit is the encoder. We take this encoder, we swap out those words with another language. We use the same encoder, making this a shared encoder. We use a decoder that is also shared across languages and perform the task of multilingual translation. That's the model. We train the system at a massive scale of 93 languages, belonging to 30 different language families and 22 different scripts. The important part here is not the task itself, but the sentence embedding that you learn. Why? We can now take this sentence embedding, where it takes multiple language inputs, and tackle various language problems one at a time using the same sentence representation. This is powerful because we can now tackle problems where we don't have enough training examples in many low-resource languages. Let's move on to photos. There are billions of photos that are shared on our platforms every day. Now, as far as a machine is concerned, photos are a bunch of pixels. We have to teach them to understand what these pixels mean. Our computer vision efforts started by understanding what is in a photo, putting bounding boxes around people, things, and as Shep already talked about, segmenting pixels and also getting pose. This is used right now in Portal and many other places. But this is still leaving out significant amount of context from the photo, the background. With our latest Panoptic FPN work, we can now see what is in the background. So for this photo, we know that there's buildings and sky, and we are actually not inside working hard, but at an offsite outside. The way we do it is we take the input image and pass it through a bunch of convolution layers and build what we call a feature pyramid. This entire backbone is the feature pyramid network. We add a branch to this that can give you instance-level segmentation of various things. This is our mask RCNN work. With our latest Panoptic FPN work, we add another branch that can do semantic segmentation. This entire model now gives us a holistic understanding of what is happening in an image, the things, the people, and the context. Text and images are static. Video is dynamic. Video understanding is an orders of magnitude harder. It comes in various lengths. We have short and long videos. We have to think about motion, understanding what is happening across frames. And it also comes with audio. So to really understand video, we need to understand all of these individually and together. We have talked about our video understanding efforts in previous F8s. First time in 2014 when we introduced C3D that achieved state-of-the-art. Since then, we have been consistently pushing the accuracy. The bubbles here, the size is the computation needed. As you can see, they're getting smaller over time and getting better in accuracy. I want you to meet Spiky, actually, in a couple of slides. This is one of the main intuitions we have is the volumetric convolution. We factor our volumetric convolution into space and time. The way we do it is we reduce the number of trainable parameters, and this makes the training faster and is more accurate. Now, I want you to meet Spiky. That's my in-law's dog. Actually, he's going to help me explain various innovations we're doing in video understanding over the past year. When I first got this video, I laughed, seeing it struggle, getting the stick inside the house. And now I know many of us are dog lovers, and we can watch this all day long, but we don't have that much time. Neither do our systems. So we use that intuition. Typically, to understand video, I want to show you that it is actually successful doing it. I know, the tech part will follow. So typically, to understand video, we take a bunch of frames, and it's all about appearance and motion. So we need to understand a bunch of frames together, and we use this spatiotemporal convolution neural network that I just talked about. And that gives us predictions for a video. But as that example showed, there are parts of video that are more important. And how do we use this as part of an algorithm? We developed what we call a salient sampler. This salient sampler quickly scans through the video and identifies the parts that are important and processes those. Now, this could be very efficient, but is also very accurate because you're focusing on the most important parts of the video. Last year, we talked about how we built world's best image recognition system using weakly supervised learning. The way we did it is use noisy hashtags to train at 3.5 billion scale and achieve state-of-the-art on ImageNet. This is weakly supervised learning. We can take this paradigm and apply it to videos. We take millions of videos and use the hashtags that go beyond scenes and objects to actions. We do this at an unprecedented scale of 65 million videos and recognize more than 10,000 different actions. To put this scale in perspective, typical benchmarks are in the order of 6 million videos, 10 times less, and can recognize over 4,000 actions, twice less. Kinetics is a benchmark where people use it to compare various video models. It has more than 300,000 videos and has 400 different actions to recognize. On this benchmark, the previous state of the art was 77.7%. With our salient sampler, spatiotemporal modeling, and weakly supervised learning, we achieve 82.8%. This is the best video recognition system and is state of the art. It's more than 5% accurate compared to the previous state of the art and reduces the number of errors by 25%. This allows us to proactively identify problematic content today. where we are able to review more than 80% than before. But I want to take a step and step back and say, even with these improvements, when we see violent videos that evade our systems, it is clear that video understanding is in its infancy. We have got to go a long way here. One such direction is making it multimodal. So video is not just about understanding visual inputs, but is also understanding video and audio together. So we take the representations from visual input and the audio and concatenate them for various tasks. We found doing this actually helps us take down more profanity and adult content. All of the methods that I just talked about, while not perfect, are helping enforce our policies right now. But as we look into the future, there is a big problem. All of these technologies are based on labeling data by humans, requiring a lot of time to build these models. We need to find new ways to move faster. That brings me to the second part of my talk, less supervision. Let's talk about how we reduce supervision. As Shep already mentioned, we have been exploring techniques on using unlabeled data to train our AI models. One such foundational technology is self-supervision. In a fully supervised pipeline, you take labeled data, you train a model for a particular task, and you repeat that, where you have another task, you label the data again, and you go on. That's slow. For self-supervised, we take unlabeled data, you pre-train a model on what we call a pre-task. This allows us to learn core representations. Now I know in the audience, you might be thinking, what the heck is a pre-task? There are many pre-tasks, and the goal of a pre-task is to predict part of the content with the rest of the content. So make predictions using context. A few examples are, in the context of a sentence, you can predict a word by masking it. In the context of an image, predict part of the image from the rest of the image. Same for audio, and video is aligning video and audio. These are a few examples of pre-tasks. What happens is, once we have trained our model using that pre-task, we learn the core representations across those modalities. We take that, and we use small amounts of label data and fine-tune it for a particular task. We do that for another task, using the same pre-trained model, and another task. The reason this is important is we have found that using limited label data, we are able to achieve more accuracy. This is the power of self-supervision. It allows us to move fast, to build core representations that can be used for various tasks that don't depend so much on a lot of labeled training data. Let's see how this works a little bit deeper with an example. This is the theme of F8 for this year in audio.
A conversation about technology and human connection.
Now I take this audio sample and mask the end of it. And now I can ask the model to predict what is that. That's a pre-task. Turns out, this pre-task is very hard. So as we are learning as humans, we know that we start with easier tasks and go to the more difficult ones. That allows us to train better. If you start with an easy task, you don't learn enough. If you start with a very difficult task, you don't learn at all. So we make this pre-task easier by making it a multiple choice. So now the model is selecting the right choice among a bunch of distractors. Turns out, this allows us to train the model in a self-supervised way, without any labels. Looking at deeper, we take the raw audio signal. We use two networks. We take the raw audio signal and pass it to the encoder network that gives you lower frequency representations that are intermediate representations. We take these intermediate representations and use the context network to predict what is in the future. As I mentioned, you can make this pre-task tougher by asking the model to predict more in the future. Think of it as I'm predicting 30 milliseconds in the future, 60, 90, and so on. By doing this, we can learn better representations. Now we take this pre-trained model and apply it for the task of speech recognition. In speech recognition, you have an audio form as input. You have a model that is predicting the words. This typically requires more than 12,000 hours of labeled, transcribed audio. With our system that is self-supervised, we can fine-tune only on 80 hours of transcribed audio, while achieving the same accuracy or a little better and that's 150 times less labeled data. The real win here is how we can now expand speech recognition capabilities to many more languages quickly, because we don't have to depend on thousands of hours of transcribed data. We take the same principle and apply it to language, where we mask a word and ask the model to predict the word. Turns out, this self-supervised model allows us to tackle hate speech with 10 times less data while achieving similar accuracy. Remember the dots that we started with? Previously, we moved one of them at a time. With learning paradigms like self-supervision, we can move towards our goal much faster and move multiple dots at the same time. Even though this will be a long, ongoing effort, I am optimistic about the fast progress towards our goal of understanding content and doing it with less supervision. Now, to talk about AI and fairness, let's welcome Joaquin Candela. Thank you.
Content moderation poses big technical challenges. And this morning, you've heard how we're using AI to address them. But it also raises very important fairness questions, because it creates a tension between two of our core values: how we give everyone a voice, and how we protect people and communities from harm. There isn't a single answer to how we strike that balance. It's a hard social question. And importantly, there is no neutral option. As we use AI to moderate content, but also as we use it across our products, we have a responsibility to surface risks to fairness and to ask the hard fairness questions. And this is why, for example, algorithmic bias is very much on our mind. But we care about it because, fundamentally, we care about fairness. And I'd like to make a confession. A while back, when I first came across algorithmic bias, I thought, how hard can this really be, right? I mean, surely someone has written a fairness library that I can, load, and I can, extract the bias from my data and from my model, and I can produce a nice, clean, unbiased algorithm that I can use, right? And then I'm done. And then this talk is done. Except it's not that simple. Unfortunately, while tools are definitely necessary, they're not sufficient, because fairness is a process. We need to follow specific best practices. For example, we need to systematically surface risks and hard questions of fairness. We need to resolve them through a process like, what definition of fairness makes sense in the context of our product? And we need to record these decisions and the process that got us there for transparency, and so we can build case studies. And it's important that we do all these things across every single step of the implementation, from defining what ground truth is, to generating labels to train our AI, to actually training an AI that can make predictions, and then importantly, to making decisions and taking actions that are based on those predictions. So before we can even talk about algorithmic bias, we need to turn our attention to the labels themselves and to whether there's a risk that we have labeling bias. And I'd like to use a really hard example of ground truth here, which is whether a piece of content contains false news. Now, on the one hand, there isn't universal agreement often on what constitutes a piece of false news. Second, at our scale, there simply aren't enough professional fact-checkers in the world. And then three, fact-checking is a process that takes time. So for these three reasons, earlier last month, we kicked off a new collaborative process to explore new ways to identify more misinformation faster. And one idea is to rely on members of the Facebook community to point to journalistic sources that can either corroborate or contradict the main claim that is being made in a piece of content. This is an example of a signal that could be useful to tell us whether something was misinformation. But now, an immediate concern, of course, is that people might bring their own personal biases, their own personal opinions into this process. And the reason this is a very big deal is that our fairness principle here is that all content should be treated the same, no matter where it comes from. So if, for example, in an extreme case, I told you that all community reviewers are based here in the Bay Area, they would not represent the diversity of the entire Facebook community. So one way we can mitigate this risk is to ensure community reviewers are diverse across things like location and age and gender and ideology. But we didn't think this was enough. So we also built metrics that measure labeler bias in our community review process. These metrics compare how ground truth maps to labels from the community. If there's a gap in how they map for different groups, then we know there is labeling bias. On the other hand, if the curves are nicely aligned and overlapping, then we're confident that we don't have labeling bias and that we are treating all content the same. What we did here, identifying risks and proposing mitigations at the ideation stage, before we build anything, is a very important part of the fairness process. And another very important part is to make sure we're not missing any important risks and to make sure we're not trying to answer all the hard questions on our own. We're currently engaging with external experts, including journalists, third-party fact-checkers, social and political scientists, and legal scholars. OK. So with this, we've talked about labeling bias. And now I want to move on to an example where labeling bias is not a concern. We're going to address potential bias in the algorithm that learns from those labels and makes predictions. And to do that, I'm going to talk about how, right now, AI and humans are working together to protect the current general elections that are going on in India from election interference. India is a very diverse country with many languages and many regions. And local and community news play a very big role in how people stay informed. Now, as we use AI to fight election interference, it's very important we make sure that that AI is working well across languages and across regions. So one specific way we use AI is to identify civic content that discusses social or political issues. And we want to make sure that we're prioritizing this specific kind of content for human reviews because it tends to be highest risk. And for this purpose, the team built the civic content classifier, which predicts how likely it is a piece of content discusses civic issues. Now, let's look at how it works for different languages. So the classifier scores a bunch of content according to how likely it is to be civic, or how likely the AI thinks that it is civic. And let's look at how these scores would work for different languages. So imagine that for language 1, although the score is 60%, in reality, only 20% of that content was civic. And imagine that for language 2, 80% of that language was actually civic. And if this was a general pattern across the board, our concern is the AI would be over-predicting for language 1, and it would be under-predicting for language 2. And if we were to use these scores to prioritize human review, we would be wasting resources on language 1, and we would not be investing enough in language 2. And the reason this would be a problem is we need to make sure that every language is getting their fair share of human review resources. All right, so we need to fix this. So one way we can fix this is by making sure that across languages, the predictions the algorithm is making are well calibrated, meaning that the scores map reasonably well to the actual outcome rates. And this here is a beautiful example where if you address the fairness concerns, if you make the system more fair, you actually also make it better and more efficient. Of course, we want to make sure that this calibration holds across all languages and that it also holds across all regions. Per subgroup calibration is a really useful tool for detecting and addressing algorithmic bias. And we've used it internally to study algorithmic bias across over a dozen products powered by AI. And the typical way you can fix miscalibration, if you come across it, is, for example, by making sure that you have enough training data that's high quality and enough high quality labels, to make sure that the distribution of that training data is representative of the kind of data the algorithm will have to predict on in the future, and to make sure that the input features you're feeding your system and the training procedures are adequate. OK, so we've talked about algorithmic bias now. And let's imagine that we've addressed our bias concerns at the labeling and at the algorithmic stages, and that we have trained an algorithm whose predictions we can trust. We're now going to turn our attention to potential concerns of bias as we take actions based on those predictions. This is what we call intervention bias. And to use a final example here, let's assume we've trained an algorithm to predict whether something was misinformation so that it can take the action of flagging it so we can potentially reduce its distribution. And first, let's look at some hypothetical data here. Imagine that we had a bunch of content and that, in reality, 30% of it was misinformation. Now, if we had a perfect AI, it would correctly flag all of the misinformation, and it wouldn't make a single mistake where it's accidentally flagging something that was not misinformation. Now, I have a question. Did you get the memo this morning? We have not fully solved AI. So as a result, any practical algorithm is going to make some mistakes. It's, for example, going to flag content that isn't misinformation, and is going to accidentally miss some of the misinformation. And while we cannot get rid of these mistakes completely, what we can do is the following. We can use a slider inside the AI to balance one type of mistake versus the other, depending on how much we care about them relatively. And so, for example, if we said, I cannot accept making any single mistake where I'm flagging something incorrectly, you could move the dial all the way to the left. And yeah, you wouldn't be flagging anything by accident, but then the AI wouldn't be flagging anything at all. So this is not really useful. Now, if you want to take it to the other extreme, you could say it's really important that the AI flags all of the misinformation. So you could push the slider all the way to the max. And if you did that, yeah, it's definitely going to flag all of the misinformation along with absolutely everything else. So that's not a very intelligent AI, right? OK. In practice, again, the way you set a slider like this is you figure out how costly each type of mistake is. And I want to take a moment to tell you how the slider works under the hood. So the way it works is we make sure the algorithm is producing scores that are well calibrated, like we discussed earlier. And then what we do is we build a decision threshold that we compare against those scores. So if a piece of content, for example, has a predicted score of 40%, sorry, if we set the threshold to 40%, is what I meant, and you have a piece of content with a score that's greater than 40%, then it will be flagged. If that score was smaller than 40%, then it will not be flagged. And the reason that it is important to pause for a moment and understand how the slider works is that that slider is how we implement interventions based on predictions. And now we're ready to talk about fairness. So in practice, you can break down content by where it came from, like what language or what region. And if you were to look at the statistics of that content over time, you would find that the ratio of misinformation, for example, per group will fluctuate, right? It'll change over time. And if you took a snapshot and you compared across groups at a given moment in time, you would find that the ratio of misinformation is likely to be different across groups. And of course, if you have an AI that's doing its job, it is going to flag more content from groups that have a higher ratio of misinformation. And that is consistent with our fairness principle here, which is to make sure that we're holding all content to the same standard, no matter where it comes from. And the way we do this in practice using the slider is this. We make sure that the scores the algorithm is predicting are well calibrated for all groups, and we make sure that we're using the same decision threshold for all groups. We did also evaluate other fairness criteria based on some of the numbers in those error tables. And the problem is, most of these other criteria force you to use different decision thresholds for different groups. And the problem with this is that if we were to implement this, then we would not be holding content to the same standard across all groups. So that's not what we do. We make sure scores are well calibrated for every subgroup, and we make sure that we're using the same decision threshold across the board. So I've shown you some examples of how we're looking at fairness concerns as we build AI into our products. And some of the key things that we've learned are that we need to surface the hard fairness questions. We need to resolve these questions through a process. And we need to record those decisions and the process itself. And we need to be doing this at every step of the implementation. Now, many of the questions that will arise are hard, and some of them are going to be hard social questions. Therefore, it's essential that the external community is an integral part of this process. And while tools are useful, and in fact necessary, and you should absolutely download and evaluate fairness libraries from GitHub, please remember that they're not sufficient for addressing fairness, because fairness is a process. And now, to talk about hard ethical questions in design, I'd love to introduce my dear friend and colleague, Margaret Stewart.
So this morning, we've already heard about lots of examples of the role that technology is playing, and particularly AI, behind the scenes in keeping people safe on our platforms, and how we need to monitor the use of AI carefully to avoid unintentional harm through bias. But the way that people experience and interact our products matters a lot too. It's really critical to understand the human side of responsible innovation and how the interfaces that we design for products can impact people in society in good and sometimes not so good ways. When you look at this, what do you see? Words, pictures, buttons, maybe functionality, possibilities, things you can do, new things that you can unlock if you click or press or read. I see values. Now, what do I mean by that? Well, let's take a few steps back and I'll try to explain. I spent the last 25 years of my career designing global platforms that have given billions of people access to powerful communication tools. People that in the past used to not be heard. And I used to believe that we were creating agnostic containers, vessels for other people's ideas, beliefs, hopes, and dreams. And it is true that these platforms have provided voice and access to billions of people that hadn't previously been heard through traditional channels. But the events of the last few years have been a reminder of something that's always been true. Design is not neutral. This belief that everyone should have a voice and access to tools to amplify their voice is not a neutral position. It is values-laden. And those values, they carry consequences at scale, and it has to be managed with the utmost care. Every time we design an interface for a product or a feature, we're making decisions on behalf of people, decisions that reflect our values to the world and can affect outcomes for people everywhere, whether or not we intend to. Now, unfortunately, getting things right is not as easy as saying, be responsible. There can be really tough trade-offs that we have to consider in the biggest and sometimes even the smallest decisions. Responsible design is about being intentional about those decisions, being cognizant of the values that inform the decisions, and doing our best to anticipate the impact that those decisions might have. And we also have to be careful to not define the potential impact of our products too narrowly, but to take a broad view of the social and political context in which they operate. Now, to show you what I mean, I want to walk you through a couple of examples to explore the different dimensions of responsibility through design. And I want to start with one of the hardest problems that we face, which has already been mentioned a bunch of times today: misinformation. Now, people on our platform share a lot of high-quality information, but sometimes, whether or not they intend to, people share misinformation. And this misinformation can be particularly harmful when people need to make consequential decisions about who to vote for in an election or making an important healthcare-related decision. So how might we use design to reduce the harm that can be caused by misinformation while still erring on the side of free expression? Early on, we tried a bunch of things. For instance, we worked with third-party fact-checking organizations to flag misleading content in people's feeds. But that just drew more attention to the content, which is exactly the opposite of what we wanted. Good intentions, not so good outcomes. So we took the time to talk to people in the community and also to external experts. And we conducted a lot of research, not just in the United States, but all around the world. And we found that across the political spectrum, and in every geography where we did research, people wanted to get better at determining for themselves the credibility of information that they came across. So we designed tools to help people determine for themselves the reliability of articles on Facebook. So for instance, for every article in the feed, you get a little button that has all kinds of context behind it. Information on who posted the article, other articles by that same source, articles on the same topic by other sources, stats on who's sharing it, even a map where the article is being shared from. But the button only works if people see it and click on it. And we noticed in testing that people weren't necessarily seeing the button, so we animated it with what I call UI jazz hands. Now, we don't use this effect very often because it creates a little bit of visual noise in the interface. But it does show you how important it is that we help people to discover this information. That's our value showing up in design. Now, we'll never totally eliminate misinformation from our platforms, and we still have a lot of work to do to reduce the impact. And we need to solve really difficult questions like, how do we get better at reducing misinformation in encrypted environments? How do we ensure that news sources of information are not unfairly disadvantaged by a natural bias towards known and trusted sources? Because we want to make sure that new players have a chance to share their work, since the unknown voices of today could be the trusted source of tomorrow. Now, looking ahead, we're going to continue to face serious challenges combating misinformation, but our teams are making important progress. But let's look at another kind of design challenge, the kind that doesn't usually make headlines. People come together on our platforms to share all kinds of exciting life events: the birth of a new baby, an exciting new job, and of course, celebrating the birthdays of all their families and loved ones. But there are also times when tragedy strikes and somebody passes away. And in those moments, sensitive and complicated decisions need to be made about what to do about their online profiles and accounts. This is an emotional process, particularly hard when a death is unexpected. This is true for me several years ago when a close friend was fatally injured in a bicycle accident. And maybe some of you have experienced something similar. And if you have, you can appreciate the highs and lows that happen in the aftermath. The incredible therapeutic benefit of having a place to come together and share memories and your grief, but also sometimes the frustration and even the anger when products don't handle the situation as sensitively as we want them to. As a developer or a designer, the question, what happens if my user dies, is not usually top of mind. Even though, in addition to being born, it's really the only thing we all have in common. But just because it's a common occurrence doesn't mean that it's a straightforward scenario to design for. We call this process memorialization to reflect something that we learned hard early on in the process. That it's not just about the person who's passed away and their account. It's also about designing the experience for the many, many people who knew and loved them, grieving in the wake of their passing. And our approach to memorialization has evolved a lot over the years. Initially, we defined the problem too narrowly. See, accounts of the deceased, sadly, are particularly prone to being hacked. And understandably, we wanted to lock that security threat down, so we allowed anyone to memorialize accounts. But friends and family told us that when a stranger memorialized their loved one's account, they felt like they weren't in control of the process or what was being communicated to the broader community. Because when you memorialize an account, the profile changes to saying remembering, indicating the person died. So while we were protecting the account from hackers, we weren't supporting the family's need to manage the process themselves. And based on this feedback, we changed it so only friends and family could memorialize accounts. But we also learned difficult balancing act between respecting the privacy preferences of the deceased with the needs of their friends and family. For instance, you can set your profile to not allow anyone to post on your timeline, and we have to respect and preserve those settings once somebody's passed away. But that means that loved ones can't use the timeline to gather and pay tribute with memories and stories and support. So recently, we've evolved the experience, and we've created a new tab called Tributes, right next to the original timeline, so that loved ones can share their memories and gather together. But we kept learning over time. We did more research, we consulted with experts, and we discovered just how complicated it is to get it right because of how incredibly personal the grief process is. Years ago, psychiatrist Elizabeth Kubler-Ross developed what she called the 5 stages of grief, and you may be familiar with this. It was intended as a way to give people permission to feel all of these things as they're grieving the loss of a loved one. But unfortunately, the idea caught on in popular culture as this very specific path that people are supposed to take as they grieve. Now, more recently, social scientists have debunked this myth of a linear grief process because there's no right way to grieve. People can and do bounce in and around all these dimensions. In fact, my friend that I mentioned before who died in the bicycling accident, sometimes I log on to Facebook and I message him to talk to him or to tell him that I'm missing him. And that might seem a little bit silly because he died over 5 years ago. And partly that's denial creeping back in, but it's also what researchers call continuing bonds that need to feel connected to the people we love long after they're gone. And the reality of this fluid and highly personal process makes it an incredibly difficult design problem to solve for. For instance, sometimes friends and family, they're not emotionally ready to memorialize an account. There's something about that step that feels like an act of finality, and we have to respect that and let them come to terms with the death in their own time. But if the account isn't memorialized, we risk upsetting other people by possibly recommending the deceased as someone to introduce to other friends or to add to a group. So we built a classifier to detect and hide suspected deceased accounts on Facebook in places where it might be distressing. And things get even more complicated when you think about designing for this scenario across the globe. You have to remember a huge percentage of the people who use our products are outside of the United States. Now, recently, we conducted in-depth ethnographic research on this topic around the world. And the one thing that held true across all geographies is that people find support from the community after they've lost someone. So it makes perfect sense that Facebook can be this incredibly powerful and supportive platform when people need to come together to grieve. But we also discovered critical insights that show just how culturally diverse the grieving process can be. I'm just going to share just one example that we learned. As I mentioned, for many people, they want their loved one's account to live on as a place to gather together and pay tribute. However, when we talked to some people in Indonesia, we learned that some of their families' religious beliefs say that a loved one's soul might be kept from entering heaven if photos of them are still available. So they might want the account deleted completely and immediately. So let's review the product requirements. Protect my loved one's account from being hacked. Don't memorialize my loved one's account without my permission. Respect my own privacy wishes after I die. Give me access to my loved one's account so that I can pay tribute. Don't delete my loved one's account because I want to use it as a place for tributes. Delete my loved one's account immediately, or they might not go to heaven. This mapping of these demands makes my head and my heart hurt because they're all completely legitimate requests, but some of them are also completely in conflict with each other. Now, I've always felt as a designer that my job was to simplify the problem so that it can be solved, ideally in a way where design gets out of the way. But here's the thing. There's no responsible way to simplify the grief process, and there's no way to stay neutral in how we design people's path through their grief. Now, this kind of problem may not make the headlines, but the way something like misinformation does. But it can be completely devastating if it happens to you. Responsible design is not just about the problems that are affecting everyone, but it's also about caring for the individual experience, especially when people are most vulnerable. We will never get it right for everyone every time, but we have to keep trying. Now, as you can see, neither of these examples are buttoned up, clean design solutions. There's still so many open questions and challenges. And that's the reality of platforms like Facebook, WhatsApp, Instagram, Messenger, Oculus, and many more across our industry. They were all born from the belief that democratizing powerful technology is good for the world, and that you create access to that technology by greatly reducing friction in the system. But we have to be aware that it's that very reduction of friction that makes it impossible to ever reduce harm to zero. And that can be hard to stomach when your goal is to do good in the world. And it's hard because no one has ever done this before at this scale, so there's no obvious playbook to follow. This has definitely been the most challenging shift in my career, but I also believe it's the most important work I'll ever do. It's a journey we're all on, and the key to the journey is to hold ourselves accountable to the highest standards of responsibility by accepting that design is not neutral, and by being clear about the values that are driving our design decisions. We can learn from our mistakes, we can respond quickly as new forces come into play, and we can stay focused on always seeking to innovate and design responsibly. Now, I've talked a lot about how our diverse global audience is a key area of focus for us. Now I'd like to invite my colleague Lade onto stage to talk about the ways in which we're ensuring that everyone can benefit from the value that our products have to offer. Thank you.
Last year, I was on the Portal software quality team. While recording a test, I noticed something. Seated next to my white male coworker, I began to talk about what I had for breakfast that morning. As I enthusiastically gesticulated about the amazing French toast that I ate, I became the visual point of interest, the obvious visual point of interest. And yet, Smart Camera started to pan and zoom in on him instead of me. Now, Smart Camera is one of the hero features on Portal. It dynamically frames people in the field of view. The fact that Smart Camera didn't work the way it was supposed to, for me, got me thinking about the bigger picture of building AI products responsibly. After combing the internet, internal resources, and even research papers for a solution, I came to realize that there was no gold standard for development. So I started to build what I could not find, a process for inclusive AI. Now, most AR/VR product experiences are powered by computer vision or voice AI technology, or the combination of the two. When AI meets people in computer vision or voice, there's inherently representational risk, or the potential to reinforce marginalization of often underrepresented groups. This is because the enabling technology must learn and understand representational physical attributes. This risk, when unmeasured and unmanaged, can point blank make it feel like the technology isn't made for you. Inclusive AI is a framework that manages this risk. After my personal experience with Smart Camera, I wanted to dig in and learn more. So I did two things: measure the representation of the existing training dataset and connected with the engineering team to run a distributive performance analysis on the model. We uncovered uneven representation in the dataset for skin tone and gender presentation. We also saw uneven performance in the model across these same two dimensions. After improving dataset representation and making system changes to Smart Camera, we were able to successfully validate uniform performance for these dimensions, and at both the algorithm and system level. In doing all of this before launch, we made sure that Portal users did not have the same experience that I did. While Portal demonstrates one application, what does a complete process for inclusive AI look like? Our process for inclusive AI is defined by three distinct yet integrated areas: user studies, algorithm development, and system validation. For each of these areas, the inclusive AI process provides practical guidelines to teams that are all anchored by a core set of dimensions. For vision, there's skin tone, age, and gender presentation. For voice, there's dialect, age, and gender. Over the past year, inclusive AI has grown from a concept to an operating framework that we have introduced into the workflows of several product teams. Let's take augmented reality, for instance. While fun, AR effects are powered by some super serious computer vision technology. The fundamental question with effects triggered by hand gestures, for instance, is can the model even recognize that a hand is in view of the camera? Skin tone and lighting conditions play a big role in answering this question. This is because in the same way skin tone looks different to the human eye depending on the lighting conditions, it also looks different to the camera, and the camera needs to be prepared for all of the possible combinations. Applying the inclusive AI process, we designed and collected data sets for the hand tracking model that had various skin tones under different lighting conditions. And we evaluated model performance to test for any variations across the skin tone spectrum. With these process steps, we went from your typical average accuracy assessment of the model to a per skin tone understanding of model accuracy. Ultimately, this work validated the inclusivity of the new hand tracking model before it shipped to app surfaces. And now, this type of measurement is fully automated and baked into the team's development flow. In addition to Spark AR, we also partnered with the Messenger Art team to create more diverse videos for testing of newly designed AR effects in Spark AR Studio. This effort came out of the art team's need to test new effects on more diverse face shapes and skin tones in different lighting conditions, and so much more. Any new AR mask now needs to be tested with these videos. Incorporating the inclusive AI process ensured that our augmented reality effects work for our diverse product community, no matter the use case. Spark AR and Messenger represent teams across Facebook that are building with inclusivity in mind, from concept to launch. Teams are designing data sets that include equal representation for critical dimensions, like skin tone. Teams are now measuring model performance within the individual subsegments of the age spectrum, and more. And teams are grounding system testing in a diverse range of user scenarios. Now, that's just a snapshot of the process that we are applying in computer vision. Another thing that we are actively solving for is voice. We've been working on using voice commands in VR for some time, and we now have the opportunity to integrate inclusive AI development principles into our effort to relaunch voice on Oculus products. This product will be built with representative data across the dimensions of dialect, age, and gender. And within each of these dimensions, we're checking for uniform performance. Once more, the application of these development principles will ensure that certain users in our diverse product community do not have a lower quality experience than others. We are far from finished. Voice AI best practice development is underway. But the computer vision best practices that we have developed are now scaling to become a part of the processes of all teams, building for the future. Collectively, we're sharing insights expressing concerns, and asking very challenging questions, all for the purpose of scaling proactive solutions for the responsible development of our products. And now, to talk more about representing our full selves in VR, please welcome Ronald Millay.
Imagine being able to live anywhere in the world and eliminate commuting, or sharing a special moment with a friend halfway across the world. In the future, augmented and virtual reality are going to allow us to connect with anyone, anywhere. Billions of people will be able to meet, work, collaborate, and play games in AR and VR. Now, to build that future, we need to enable a deeper sense of connection within AR and VR. You need to feel like you are physically present in the same space as someone else and communicate your ideas and emotions effortlessly. This includes things like facial expression, gestures, tone of voice, and so on. Now, to feel completely present, we will need lifelike avatars. So Facebook has worked on virtual avatars for several years now. Our codec avatars, for example, are ultra-realistic avatars that allow two people to interact in real time in VR. They've come a long way, but there's still a lot of work to do before they ship. Now watch this playback of a conversation between Nadia and Dan via their avatars.
What do you do for exercise?
I do yoga and then I do boxing too.
So sensors on Nadia's prototype headset measure her facial expressions, translating them in real time so that Dan sees a picture-perfect representation of Nadia's face, facial movement, and voice. Our codec avatar technology has shown groundbreaking realism when capturing faces, but genuine human communication requires the full body language. And in some cases, nonverbal cues are even more important than verbal ones. For example, take a look at this image and see what it tells you about the state of mind of these two people. Now, look at this collection of points and see what happens when we animate them. Like, even a collection of dots carries information and communication when it's in motion. Motion tells us about engagement, agreement, trust, and empathy. The technology used to study and capture human motion has come a long way since Edward Muybridge's pioneering work in the 1800s to motion capture in dedicated studios and, more recently, on-set performance capture. When I worked on these technologies at Lucasfilm a while ago, we had to deal with sometimes uncooperative A-list actors who were somehow becoming reluctant to wear a tight spandex suit like this one here. So it got us developing a new kind of markerless motion capture technology. Now, the problem with this approach is that, sure, you do look a little goofy in that suit, but it also requires a lot of hardware and a team of dozens of highly skilled artists using an enormous amount of reference data and working for months to build a single avatar. So clearly, nothing scalable for broad use in VR. Another challenge is giving people the ability to customize their avatar. I mean, altering our physical appearance is part of being human, after all. People shave their beards, they dress up, they put on makeup in real life. So why not allow them to customize their avatar size, gender, muscularity, posture, style, or just clothing? But then how do we preserve the essence of a person in an avatar when they change their look? Well, it turns out a big part of it has to do with how we move, how we use space and time. Every person has movements that are unique to them. For instance, an individual may talk with her hands, or tilt her head a certain way, or shuffle her feet. These motions and dynamics are a key part of her personality and expressivity. They're the way many of her personal traits and emotions are conveyed. Capturing them lends authenticity to avatars. But if you're going to replicate something as nuanced as a strut or a nervous tick, you first need to understand how the human body works. So an individual's appearance and motion is the product of many complex and deeply interconnected elements.
Like your brain controls your muscles, which drive the bones, which in turn move the tissues and the skin, and finally, the fabric of clothing on top. So in order to reproduce all of these and render a complete 3D avatar with data from only a limited number of sensors, we need to use a body model that replicates the human anatomy. This model needs to be fully adaptive to perfectly match any individual automatically, and it needs to be physically based to replicate actual, genuine behaviors. So how do we do it? Now, to build that model, we start from the inside out. So first, we study medical literatures and used advanced medical imaging references to design an anatomically correct human skeleton with the proper articulations and degrees of freedom. So that model is far more complex than those used in traditional animation. Think of how your shoulder blade slides, like your hips roll, or your joints stretch even a little bit, just to enable you to do the subtle gestures that are unique to you. Next, we match the skeleton to the user's body structure and animate it in real time. And as the user moves around, the model continues to adapt to this unique individual and is more faithfully able to reproduce that person's movement. So as you can see in this video, the skeleton is matched with Tony, one of our researchers, who is observed by a single sensor. And notice how subtle motions like the shoulder roll here are accurately captured. We can't stop at the skeletal level, though, where it looks a little creepy. And what really drives the motion of the skeleton are the muscles. Now, the muscle movement is critical to understanding behavior and intention. So this sequence here shows real-time tracking of Tony's muscle activation. Now, to do this, we use the inertia of his body and the musculoskeletal system to help us predict and stabilize his motion. Modeling the deformations that occur when the muscles contract is also critical to creating a realistic reconstruction of the body. Now, of course, skin, hair, and clothing are the most visible layers. And for clothes and hair to interact realistically with the body, we need to reconstruct and simulate them as faithfully as possible. So here we use visual observations to infer the body geometry and reconstruct its shape. And then we apply physics-based model to reproduce actual cloth deformations. And we need to be able to accurately match people's actual garments, even under challenging circumstances, like this here. All right, so now let me show you what this looks like in an early prototype of a simple live interaction. So here you'll see two people, Alex and Tony, who could be remote in different locations, animating their avatars in a shared virtual environment, that soccer field on top. So keep in mind that doing this without any suit or marker, in real time, with minimal hardware for capture, is groundbreaking. So let's take a look. And watch her reaction here, how she jumps. Like she's totally immersed in the experience. This is very cool. Now, as you can imagine from that example, latency will be critical. It's one of the big challenges we need to overcome before this turns into a shippable product. We also need a way for people to easily generate and animate their avatars using off-the-shelf sensors. Now, before we ship this, we also need to make sure we answer some key questions around privacy and security. One of the questions is making sure avatars are authentic. And there are a number of ways we can do that. For example, we can make sure your avatar is tied to your account and your identity. To prevent others from accessing your avatars, security and identity verification options will also be key. So fingerprint and facial recognitions are already used in mobile devices around the world, so building them into future devices may ensure only you can access your avatar via your device. Another critically important question is how we make sure these body models work equally well for the vast diversity of body shapes, sizes, skin tones, and clothing in the world. So we're making sure our data sets are as diverse as possible to prevent issues like Lade talked about earlier for Portal. So obviously, we're still years away from this type of technology reaching consumer headsets, but we're already thinking about these questions, and we're confident we'll land them before this ships. Developing realistic avatars may be one of the most important factors in making VR and eventually AR a part of our everyday lives. It's going to enable billions of people to work, meet, and play with anyone, anywhere in the world. Just imagine teleporting to your job or being truly present at a family birthday party halfway across the world. This ability to defy distance and break the link between where one lives and how one's able to make a living, or the friendships one can have, will be transformative. Like, what a gift that would be. This is what drives my work. So I've talked about the future of AR and VR. Now, to tell you more about what we're doing today to bring people together and keep them safe in VR, please welcome Lindsay Young. Thank you.
The future you just saw, one where you're represented by full-body avatars and can feel instantly present with other people, where you're at play or at work and everywhere in between, that's the promise of VR. And we all know what it feels like to be really present with someone. This is my mom watching Murder, She Wrote with a baby. That's me. No wonder I love true crime. But many of you might not yet have experienced what it feels like to be truly present with others in VR. See, now I can sit on the couch with my mom and watch Red Table Talk, despite living on opposite sides of the country. So I'm not just messaging her during the show, I'm right there with her, as if we were still in the same place. And anyone who has felt this connection in VR can tell you that it is transformative. We envision a world where these meaningful connections and communities can form in VR, where the needle starts to shift from early adopter to everyone. I work on safety and integrity products to make virtual reality experiences an inclusive and meaningful place for everyone. This includes preventive systems, like products that foster respectful culture and camaraderie among VR users, and reactive systems, like reporting, blocking tools, and more. We believe VR is the next frontier of human interaction. So it's an area we need to be incredibly mindful of when building. VR is powerful, but it can also be intimidating. That's the challenge with this technology. And as we bring people together in VR, they should have access to tools that help make them feel safe. Part of this is the opportunity to shape what safety even is in VR. In our day-to-day lives, we know there's etiquette in how we interact with other people. You don't skip the line or cut somebody off in traffic. And if this does happen, you can take action to stop that behavior. VR has very similar social norms to what we have in our everyday lives. But because VR is so new, how those norms look or feel may not yet exist. And although we've learned a lot from Facebook apps and the integrity challenges that we face, an experience in VR is different than one you might have in an existing 2D community. So we can take environmental cues in the physical world and recreate those in virtual spaces. We can do that as those who create the platform, but so can you, the developers dreaming up experiences for people. Together, we must create these norms. So that means there's a learning curve for everyone. Our teams here at Facebook have been stewards of both the platform and first-party apps that are helping to weave the social fabric of bringing people together in VR. And we also built VR apps with safety in mind. When we released social apps like Spaces, Venues, or Rooms, we incorporated safety into the core design of the experience. And we've learned a lot from building these experiences in a few short years, including what works and what doesn't. We've learned what works one-on-one, when friends catch up and play board games at home. Or when you're one of many, joined with crowds of people to watch a concert. These apps have served as a test bed for our safety tools and norms in VR. And we've built several tools that give people control over their experience. For example, we introduced a safety bubble, which serves as a boundary for your personal space. This shield prevents other people or objects from coming closer than you'd like. So if one avatar enters another's safety bubble, then both avatars become invisible to each other. We also introduced other features, like pause, which allows you to take a break anytime you're in a space where you don't feel comfortable. Or mute. If someone in your space is making you uncomfortable, you can choose to mute that person by disabling their audio. And we had to think of new safety and integrity tools, like real identity, when we started building apps that had you interacting not only with your close acquaintances, but also with people you don't yet know. This was the case with Venues, our app for live events in VR, where thousands of people are in one space together. Before entering any live experience, people view through this video that helps orient them to the social norms expected there. It also explains what tools are available to you. And the thing that makes me feel most safe is having control. So you can block or report someone and attach a short video so moderators can review and take action. And just like you might have security at a stadium or concert, there is live moderators on hand to help enforce good behavior. These behavioral expectations are the foundation of the type of culture we want to have in these communities. So if people violate these expectations, they can be blocked or removed from future events. Repeated abuse could also lead to a suspension from our entire platform. And while we've focused on learning from our first-party social apps, we know that providing safety and integrity tools to our community is key. So we have a code of conduct for anyone who owns a headset. And that includes people in the experience just as much as the people building them. And we've seen shining examples of putting user safety first from our developer community. Take, for example, Harmonix. When designing the multiplayer lounge in Dance Central, player safety features were high on the list of priorities for the team. Through research and personal experience, they learned that harassment and griefing situations often occur in social and multiplayer experiences in VR, just like they do in real-world dance clubs. They knew they needed a quick and easy way to de-escalate situations without entering a menu. But we're also challenged with figuring out a unique and deliberate gesture for players to perform, knowing that movement is constant in a dance game. This led to their creating the double thumbs down, a gesture that gives players the power to mute and freeze their offenders, and the offenders a visual signal that their actions do have social consequences. Once the gesture has been detected, a countdown timer appears before the offending player is muted and routed to a predetermined location on the dance floor, acting as any other crowd member would. This can easily be undone by looking at the offending player and giving them a double thumbs up, or unmuting them. We applaud devs like Harmonix and so many others who build for people and their safety. And we've seen some early bright spots, but know there's room to improve. It's still the early days, and our best practices will grow at the same pace that tech evolves. So we're committed to listening, learning, and adapting. And as we embark on the next experiences that will bring people together in VR, we're building upon our learnings. We created a toolkit that focuses on integrity and provides a framework for all teams to build social products or experiences. And the thing I love about this is that it gives the people I work with the tools and language to design and build for integrity and safety. So for those of you in the audience who want the same level of buy-in from your teams, let me share a little bit more about how this toolkit works. It focuses on two aspects. The first is the traditional way of thinking about integrity problems. Something happened, and I didn't like it. What tools are available? What can I do now that the bad thing has happened? Things like blocking or muting. But the second way is to focus on fostering a strong culture by taking a culture-first approach to building. What are the healthy norms we are establishing? Are we building a community that is welcoming and supportive? How are VR communities adopting their own culture, filled with camaraderie and curiosity? Communities that thrive and are full of possibility? These are things like recognition systems or ambassador programs. And we make it a requirement for any team building a social VR experience to answer these questions. We plan to leverage what we learn to help the community build social VR experiences. So we'll take what works and build it into our platform SDK. You may have guessed that everything I'm talking about is representative of real work and real products. And we're excited to share more at Oculus Connect. The next phase of social VR is on the horizon. Until then, we'll all keep building responsibly. Thank you, and enjoy the rest of F8.